Hi, welcome to the channel. Today I wanted to talk to you about the composite wing that came on my Lamborghini Gallardo Superleggera. And this is an OEM wing, and when I first bought the car, it might have been legitimately almost falling off the car. And when I took it apart, the failure mechanism was a lot worse than I originally expected. So I figured it would be a good opportunity to show you what goes into manufacturing this part and show you the failure mechanisms that occurred, and also talk to you about why I can't really be mad at the engineers that originally designed this wing for the failure mechanism that actually happened to this part. So a little bit of backstory behind my experience is that I used to work in the composites engineering field, mostly in manufacturing. And so I always jump at the opportunity to take carbon fiber parts apart and also show you what it entails to build something like this. So first off, I wanted to show you what actually happened on the car and why I think it failed in a certain way. Then we're going to take it to the bench and I'll show you the exact failure mechanism that occurred on the certain parts of this wing, and maybe we can go into a little bit of the engineering behind it. And then I'm also going to show you how I fixed the wing, and then maybe at the end we can talk about, does this wing actually do anything? Let's talk about it. So when I first got the car, I noticed that this gasket was a little bit misplaced on the car. You can see that it's like flush on the other side. And then I noticed that the whole back end of the wing is loose. So that's interesting, right? And this is an OEM Superleggera wing. So I think what happens is there's the trunk latch right here. And when you go to push down onto the trunk to close the engine bay, you naturally want to like kind of put your arm on the underside of this wing. And I think that's what caused it to fail. So I'm going to take this wing off. It just comes out with 3 little bolts underneath. And I'll show you what I found because it's a little bit interesting. So I got the wing on the bench, or in this case my CNC. And first off, I think it's just a wonderful piece of composite engineering. I weighed this, and this whole thing is only like 2.2 pounds. And I think it's about 3 pieces. So you have the main wing element, and then you have, well, 4 pieces. And then you have the wing struts right here that are bonded in with epoxy. And then you have these plates that are also bonded to the wing struts. And then you might have this on your car or not. It depends on if you got it from the factory this way, but this one has a backup camera, and it's just another nice piece of, another nice composite piece. So I'm pretty impressed with this overall. And this is the mount. This actually goes onto the trunk lid. But I'm pretty impressed with this, but I actually found failure on, that's actually worse than what I expected. And it's on these 2 wing mounts. So I'm going to show you exactly what happened, and then we can go into fixing it. But this is a very expensive wing, but I think we can fix it. So I'm happy about that. So the first issue I found was the fastening method itself. And these are called rivet nuts. So there's 3 facing towards the forward of the car, and then there's 1 in the rear. And this side is fine. I don't even think these are stainless steel, but on the right side, I actually had a tear out, and you can see that right here. And then the tear out kind of propagated, and I have a fracture that leads up this way. You can kind of see that crack as it kind of comes up. So really not ideal. I honestly would rather prefer to use a click bond for this. I don't know if click bonds existed when this wing was made. I'll show you a little picture right here. But basically you put it underneath, and then you can have some sort of adhesive on the back side of that. And then you can, it like clicks into this little hole, and then the rubberized portion that is connected to the click bond maintains a proper glue gap between the composite and that little piece of metal. And then you can have a threaded insert that distributes the load a lot better than this riveted in fastener. So I have an example of this riveted in fastener. So imagine that you have a pre-drilled hole, and then you can use a special tool that pulls on the inside of this, and it actually compresses that. See that textured region on the outside? It actually compresses it in between this lip, and then you're gonna have the piece of composite or piece of sheet metal sandwiched in between the two, and then you have a fastener. But in this instance, it's actually gonna cause a huge stress concentration, and you get a brittle failure just like this. So really not ideal. In this side, we have another problem where I said that the foot or the mounting point was actually bonded to this little plate right here. And what happened is I actually got a failure. So this part is actually coming off of the mounting leg, and it's not in the adhesive. This is adhesively bonded. I think it's actually in the carbon fiber matrix. So interesting failure mechanism. Other than this, I don't think this is really that bad. Ideally, I'd use a clip bond like I said, but I think there's a reason why they use 2 fasteners in the front and then 1 in the rear, because this is facing towards the front of the car, and then this is like the rearmost portion of the car. And I'll show you why I think that, because I think they did it for a good reason. They just didn't really consider the human interface factors behind this design. So I said previously that I thought that failed because when you put your hand to close the trunk, you kind of have a tendency to lift up on the wing. And I don't think the engineers ever accounted for that. So my theory is that, let's say this is mounted on the car, and then this is the front of the car, and then this is the rear. So you're gonna have two force vectors that are getting imposed upon this wing. And then let's speculate that there's a distributed load all the way across this wing, but we can resolve it into one point. And let's just say the point's like right here. So you're gonna have a drag vector component, and then you're gonna also have the drag vector is pointing this way. So you're gonna have a drag vector component, and then you're also gonna have a downforce component, right? So the drag vector is probably gonna wanna make the wing go this way, and then you're gonna have the mounting points underneath resisting that. And that's why I think that there's two bolts underneath here. The downforce component, right? It's gonna evenly distribute through these mountings, and I don't think you're gonna see the failure mechanism that we experienced on this wing, personally. So I think it really is from them not really considering the environmental factors and the human use factors that would go into like just physically closing the trunk. And I wonder if, like on the 2nd gen Superleggera, if they actually went ahead and fixed this. But who knows? I don't have a 2nd gen Superleggera, I have a 1st gen. So maybe it's something you need to look out for on your car if you have a Superleggera. And I'd like to hear it if you have an LP570. I'd like to hear if these mounting points were revised or not. But I can't really criticize the engineers that much. I just don't think they really considered that. And that probably would be something that they snuffed out on like a second revision type part. But what do I do to plan to fix this? So the disc bond right here, I'm gonna use a JB Weld plastic bonder, and JB Weld is just excellent. They have excellent products. I've used them for years. This is different than just regular JB Weld. This works really well in composites, fiberglass, stuff like that. There's all sorts of composites or composite bonding techniques that you can use. But this was $7, works for carbon fiber composites, and should get us down the road. The only thing I really don't like is that I don't know if I want to take this part out or not, because it's disc bonded all the way through here, and then it's still holding on in the rearmost region. So I ideally would like to take this whole thing out, do some good bond prep by like sanding it and making sure it's you can get good adhesion with the plastic bonder. But what I might do on this one is I might prop it up and then just put the plastic bonder inside this interface. And I think we should be good to go for this side at least. I also plan on drilling out this rivet nut and replacing it with a little bit of a different fastening technique that I have planned for the other side. And I was thinking while I'm in there, I can do it for this side, for the side that's disbonded. since it might fail in this mechanism instead of disbonding again. But there's no disbonding on this side, so I'm gonna leave that the way it is and then just make revised hardware for this. But I'll show you the hardware that I plan to use for this one. Okay, so I got the resin mixed up. I got the wing mount bonded or cleaned up. And now I am going to use a syringe to try and inject it into that little cavity. And I just went around the whole perimeter and then clamped it down afterwards and then let it dry after clamping it. All right, so the repair is finished and I think it turned out beautiful. There is a small lip, but I don't think it's gonna matter in terms of like mounting. It's almost imperceivable, the repair, can't really tell. Unless you watch this YouTube video, of course, but that's a different story. Here's the other side for comparison. I also took the liberty of taking that little rivet nut out. Now we can go over the fastening method I plan to use for this repair. So I got some new fasteners, and I'm going to use a set of M5 button head 18/8 stainless steel black oxide coated fasteners for these bolt holes with the remaining threaded inserts. And then for the one that I removed, I went ahead and 3D printed a little part, and this is going to go behind it, and then I'm going to have a serrated nut on the back side of that. I'll have a diagram for you so you can look at what I'm doing. But what I'm trying to do is I'm trying to distribute the load a little bit more effectively than it was in the past. And hopefully I can reduce the stress that the composite sees, and hopefully I won't get a fracture right here like I did on that other side. So that's the plan for this. So if you look at the bracket, you can actually see inside where the bolt holes are that the epoxy actually fractured a little bit. I mean, this part is still structurally sound and everything like that. There's no issues with this part whatsoever. But to alleviate that a little bit, I'm actually going to put a nylon washer underneath the head of these fasteners, and that should alleviate some of the load right on the outer perimeter of that head of the bolt. And another thing is that the head of this bolt's a little bit smaller, and you need a hex key to actually use it. So this hex key is a lot smaller than the fastener that originally came on the car. And my intent with that was, if you do loosen this and tighten it back up multiple times, you can't impose that much torque on a hex key comparative to when you can impose what you can impose with like a socket wrench or something like that. So that might prevent any further damage and any sort of like tear outs or anything like that from occurring. So just a little bit of attention to detail on that, and I'm going to get this back on the car and bolt it on, and we'll take a look at it. So the wing's on with the new hardware. The biggest pain in the butt was being able to get the wiring for the reverse light and the third brake light up through this wing mount and properly installed. And I was also able to even get out that gasket to I massaged it with a heat gun, and it sits all flush and nice again. So this car came with two options. You had the high wing option and you had the low wing. So this is the high wing. And the low wing is basically a derivative of the base Gallardo spoiler, but it's fixed in the up position. So what they did for the Superleggera is they removed all the actuator mechanisms from the active rear spoiler on the base Gallardo. And all the active spoiler mechanisms were located in this area underneath the engine bonnet. I really don't think that this does much. I think I read a figure somewhere that this adds about 50 kilograms worth of downforce at 150 miles per hour. Which really isn't much. I think we need to look at a couple factors to really consider if this actually does anything. One is the mounting points, right? We are only holding on with 6 M5 screws, and that's really not a lot to fasten like an aerodynamic device down. Most wings that you see that are actually functional are rigidly mounted to the frame, and this is far from that. So, you know, there's that con. And then there's also the idea that you're going to want to aerodynamically balance the vehicle, right? So if you add downforce to the rear, you're going to want to add it to the front, or you're going to get unsteady handling characteristics, and the front end might feel light at higher speeds and the back end might not. But it's speculative, you know, without getting it in a wind tunnel. But I think what it does is it simulates what the rear spoiler does. Maybe it adds a little bit more. It would definitely aerodynamically balance out the vehicle, right? Maybe the rear end of the car produces lift at higher speeds, which if you look at the shape of the car, it might be very valid. And that just might negate that. But I don't know, they added the wing, but they also didn't do anything to the front of the car, right? The front bumper is the same bumper as the base Gallardo. So I really can't see that they would actually that wing would actually do much of anything at all. So although the wing doesn't really do much, I think it really adds a lot of styling to the car, and it really completes the proportions of the vehicle. I could see why a lot of people would add this to the base Gallardo, because it looks cool, honestly. Although it doesn't really do much. So if you like this video and you liked watching me take apart carbon fiber parts, it's something I really do enjoy. Please consider subscribing and liking. And if you have any questions or comments, please leave them down below in the comment section. I'd really appreciate it, and I'd love to answer any questions that you have. So until the next video, thanks.